I got a test to hand back here.
I was watching something on the news, and it was talking about how like the local news specifically was talking about how women can see like such an increase in applications this year because we took it. Well, that's what I said, because it was a 3% increase overall, but it said for the nursing program specifically, they got 30% more applications than normal. Oh my god. So I was like, okay, but that's like they didn't change how many they accepted. So I was like, okay, that makes sense. So did you put out the gap?
All right.
So if you just deleted this one.
So, test. I feel like we're getting there. I feel like this went pretty well. I'll answer any questions you have on any of them. Yeah, Charlie. 15?
Yes. That is what I was.
Okay, so they're giving you a slope field, and they want to know which differential equation, or which of the following could be solutions to this differential equation, slope field. So I think the best way to answer a question like this is to just picture the graph of the solution on the slope field and see if it matches up, okay? And in this case, you can actually rule them all out except E. It's E. If you think about cosine, what cosine looks like is goes like this, but where does it cross the x-axis? It crosses the x-axis at pi over 2, which is like 1.5, and this doesn't look like it's going to cross the x-axis at 1.5 based on the little slope field lines. Does that make sense? That was the most common wrong answer, was A. B, 1 minus x squared is just a parabola that opens down. It definitely doesn't look like a parabola that opens down would fit on this. Does everyone agree? C, e to the x, this doesn't look anything like e to the x. D, the square root of 1 minus x squared, that's a half of a circle of radius 1, and this doesn't look like that would fit. So it must be E. I don't even know what E looks like, but all the other ones I could rule out. So it has to be E. Does that make sense logically? Yeah.
Yeah. When you do slope fields, you don't really have to like change it. You just look at the equation that they give you, right? That's what I forgot.
It depends. Sometimes the choices will be differential equations, and it'll say which of these differential equations goes with that slope field. This question is different. This question is saying which of these could be a solution to the differential equation that fits this slope field. So those are different questions. If they had given you the actual differential equations down here, then you'd have to look at the points where the differential equation equals 0, points where it's undefined, stuff like that. You know what I mean? It would be a totally different approach. Did I answer your question? I'm not
Yeah,
sure.
no, that makes
Okay.
sense. I just forgot how to do it.
Does everybody understand that? The difference in mindset? And then there's other questions where they'll give you a differential equation or a solution to a differential equation, and then the choices will be slope fields. Which of these slope fields could go along with it? So that's a different thing altogether also. Like, it's the same thing, like if they give you a differential equation and a bunch of slope fields, you look at which of the slope fields corresponds to 0 points in the differential equation, undefined points in the differential equation. Where is it positive? Where is it negative? First quadrant, second quadrant, stuff like that. That's what you'd be looking at. If they gave you a solution, a single solution, and then a bunch of slope fields, then you'd be just looking at which of the slope fields does that solution like fit into when you graph it. Okay? Where do the contour lines like match up? Okay? What else?
12.
Number 12. Okay. So this one we have f prime of x equals 2 over x, and f of radical e equals 5, and we're trying to find f of e. So what type of problem is this? FTC part 1. Yeah, I'm not. You could solve this like an initial value problem where you integrate both sides, and then you have a plus c, and you plug this in to figure out what the c is, and then So you could solve it that way, but I think that's the harder way to do this. This is actually an FTC Part 1 problem, much easier. So remember, FTC Part 1 is f of b equals f of a plus the integral from a to b of f prime of x dx. Right? Think about this. This makes sense. This makes sense because this is really f of a plus the integral of f prime, which is f, evaluated at b, and then evaluated at a, and subtracted. So, of course, that makes sense that that's equal to f of b. Don't you think? All right, so this just ends up being f of radical e plus the integral from radical e to e of 2 over x dx. Looks complicated, but this is actually a pretty simple thing once you do it. This ends up being 5 plus 2 ln x from radical e to e. So this is 5 plus 2 ln e minus 2 ln radical e. So ln e is just 1. What's ln radical e?
Aren't you allowed to do more one half or one?
Yeah, so this is just 1/2. Because if you have ln radical e, that's like ln of e to the 1/2 power, and the ln e cancels. So this ends up being 5 plus 2 minus 1. 7 minus 1 is 6. That's the answer. Oh,
Can we do 85?
yeah, 85. This is a calculator question. So we have, they were really nice and drafted for you. We have 2 functions like this. This is y equals x squared over 10. And this is y equals negative x squared over 10. And this is from 1 to 4. And cross sections are squares. So we have squares coming up out of the board, 3D like that. So the volume, generally the volume is the integral from a to b, from 1 to 4, of the area of a typical cross section. Well, the area of a typical cross section here is just s squared, right? But s is this distance right here, which is the top curve minus the bottom curve. So this is just the integral from 1 to 4 of the top curve minus the bottom curve, which is x squared over 10 minus negative x squared over 10 squared dx. And you can simplify this before you do this on your calculator. It'll make it easier and less likely that you make mistakes on your calculator. X squared over 10 plus x squared over 10 is really just 2x squared over 10, or x squared over 5 squared. Or you could even write this as the integral from 1 to 4 of x to the 4th over 25 dx. And then you just do that on your calculator. So on my calculator, I changed my calculator to degrees last periods. Back. So I have math 9. Math 9. Okay. Integral from 1 to 4. Integrand is x to the 4th divided by 25. X. And it's 8.184. That's it. Okay.
Yeah, so what I tried doing was, I figured I could just find the volume of half of the thing.
Yeah.
I just did x squared over 10 squared, and multiplied the thing by 2. I don't know why.
You'd have to multiply by 4. Because think about it, what you did is you're taking this little square right here, but if you think about it, there should be 4 of those squares that size. Does that make sense? Okay, let me try it again. If you're taking here's the actual thing, right? That doesn't look square. Hang on. Okay, you did this. You took a square coming up out of the board. But that's really, if you double it, then you're really just doing that. You see what I'm saying? There should be four of the squares of that size in the actual square. So you probably got half of the answer.
Yeah, I got it.
Does it make sense that why though? Okay. What you could do to get around that is take the base times twice the height and double it. That would have worked. You know what I mean?
Yeah, because I remember I tried 2 different ways of doing it, and I got 8.14, so my answer is first, I put the 2 outside the intervals.
Yeah.
On the second time, I put the 2 inside the interval and got, 2x squared over 10, and that gave me the right answer. But I ended up going with the wrong one. I don't know.
Okay, if you put the 2 inside, that means you squared it?
Yeah.
Okay, so that's why you got the right answer. Okay? What else?
Can we do 81, please?
Sure. 81, also calculator question.
Yeah, I don't know what I did wrong.
Okay.
I thought I knew what I was doing.
So we have f prime of x equals x minus 4e to the negative sine 2x. How many points of inflection does it have? So inflection points are when the second derivative changes sign, right? So there's 2 ways to do this. You could actually find the second derivative and then just graph it and see how many times it changes sign. So that works. So f double prime of x would be 1 minus 4e to the negative sine 2x. But you have to use the chain rule like multiple times here. This would be times negative cosine 2x times 2. Right? So you'd have to do that. Then just graph this and see how many times it crosses the x-axis and changes sign. And it ends up being 4. Another way to do this, which I wanted to show you, this is like a little calculator trick. Your calculator will not find derivatives of functions. Kind of. It kind of does. Let me show you how you can like game the system here. This is going to be x. I'm going to type in f prime. X minus 4e to the negative sine of 2x. So that's f prime, right? What you could do is you could enter into y2 the derivative of that function at x. Watch, if I go math 8, the derivative of y1, and instead of having it be at a particular x value, just have it be at x. Your calculator will then show you the graph of the function and the graph of its derivative. Without ever actually calculating the derivative, you can have the graph of the derivative, which is helpful. That's all you really need is the graph of the derivative. So if I graph these now, the interval they're giving you is between 0 and 2 pi. So I'm going to change the interval 0 to 2 pi. And I'm going to go zoom fit. So the first function that they're graphing is the function itself, y prime. The second one is the graph of y double prime. So if this is y double prime right here, you can see it changes sign once there, once there, once there, and once there, right? So it's 4 times. And if you had graphed this right here on your calculator, you'd get that same green graph. But I saved time and I eliminated any errors I might have made using the chain rule. Everybody see that trick? So instead of evaluating the derivative, your calculator only does numerical derivatives. But instead of actually picking a number, just pick x, okay? And you might be wondering, well, what if x is like stored as a number, like some actual value? I actually tested that, And it actually just uses X. It doesn't use that number X in this case, which is kind of nice. Okay. What else? The free response?
Yeah.
Any particular part or the whole thing?
I don't know. I don't know how to like ask this, but like I knew what I was doing. You said yes, but show it. I don't really know
I'm not sure what. I can't remember.
like that. I think I just like had I did that.
Oh, okay, yeah, so-
But I knew what I was doing.
Okay,
You know what I
so yeah, so in part A, if they're asking you, is the tank of the water increasing or decreasing? You can't just say it's decreasing because water is being removed faster than it's being pumped in. You have to actually say, what's the rate that it's being removed? What's the rate that it's being pumped in? So what they expected you to write in this question was actually calculate W of 15 and say what that is, 131.782 gallons per hour. And what is R of 15? Like actually calculate that and say what it is, 252.872 gallons per hour. Now you can say for sure that water is being pumped out faster than it's being pumped in. So therefore the water level is decreasing. Like, you know,
So
you have to
that
have,
was what I was missing.
yeah, you have to have numerical evidence. You can't just say, yeah, because this is greater than that, if you don't have any numbers to back that up. And then you said C, Logan?
Yeah.
Okay, so this says, at what time T is the amount of water in the tank at an absolute minimum? Okay, well, from part B, you should have gotten the formula A of T, the amount of water at time T, is the initial amount of water, 1200, plus the integral from 0 to T of W of T minus R of T, dt. Everybody agree that this is the formula to get the total amount of water at any time, okay? So if you're trying to figure out when the minimum value is of the amount, then it's first derivative test. So A prime is just W of T minus R of T. That's FTC part 2, right? But it makes sense too. The rate at which the water is changing is the rate at which it's being pumped in minus the rate at which it's being pumped out. That's logical sense as well, right? But it's also FTC part 2. So if we're trying to determine when this is at an absolute minimum, set it equal to 0, graph this and graph that to determine when they intersect each other. So you'd say WT equals R of T when T equals, it ends up being 6.495 and 12.975. Does anybody want me to do this on my calculator just to show you that that's what you get? All I did is I just graphed W of T. At the very beginning of this problem, I entered in W of T as Y1 and R of T as Y2, so I never have to worry about it again. I just graphed the two functions on the interval from 0 to 18, and then just found out where they intersect each other, okay? In this problem, finding these critical points right here is worth 1 point out of 3. You found these 2 points, okay? So then you have to determine when the absolute min is. There's a couple ways to do this. One way to do it is you could just test every critical point. Well, the only other critical points there are here are endpoints. So we have T equals 0 and 18. So one way that this would work is you could just find the amount of water at 6.495, the amount of water at 12.975, the amount of water at 0, and the amount of water at 18. Just compare them. Whichever one's the least is the absolute min. Another way to do it is you could identify relative mins. So you can make a little table for A prime, and it ends up looking like this. If you have 0, 18, 6.495, and 12.975, the table or the chart looks like this: minus, positive, minus. So there's only 2 relative mins at 6.495 and at 18. So by doing this process, you'd have to explain. You'd have to say, since the derivative changes from negative to positive, there's a relative min at that point. since 18 is an endpoint where the derivative is negative before that, there's a relative min at this point. Those are the only relative mins. And then find A of 6.495 and A of 18, compare them, whichever one's the least ends up being the absolute min, since those are the only relative mins. And that's it. So for this question, 1 point was for finding these critical points, the interior points. 1 point was for identifying the fact that the least occurs at 6.495, and 1 point was for your analysis and explanation, like showing your work and explaining why it shows what you're supposed to show. Okay.
How many points was part D?
D was worth 2.
Yeah.
You get 1 point for having the correct limits of integration, which are 18 to k, and 1 point for having the correct equation.
So how many was D worth then?
D was worth 3 as well.
So, yeah, I got a point on for not writing plus 1200.
Yeah, what were the points?
Yeah, what's
Yeah,
the
probably.
point distribution?
Or is it
Yeah, for not showing your work properly. Right? Because you have
That's what I would do.
this much, this is that,
I
that's
have the
absolutely
right
correct.
answer.
But then you have 1310 without.
Like, I have
Saying how you got it.
6.495, and I would know, but I just need to-
So the point distribution in part B was 1 point for having the correct limits of integration, and 1 point for having the correct integrand, and then 1 point for your answer. Okay, but an unsupported answer without work is like having no answer at all. So just be careful about that. Yeah. Oh, yeah, yeah.
The sentence here that says because
Yeah. You, remember a sign chart by itself, and then like if I just gave this sign chart and then tested this point and that point, that's not sufficient enough. You have to explain why that's a min and this is a min. And the reason why they do that, up until maybe like 10 years ago, they used to accept sign charts as work, like as an explanation. But there were so many different looking sign charts, different teachers teach it a different way. So they got to be like how shorthand of a sign chart are we going to accept? You know what I mean? So rather than just keep accepting like messier and messier and more unclear work, they just they said, all right, you just got to use some words and explain that you know what you're doing. Yeah.
So, how much was part A worth in total?
A was worth 1 for having the
B
correct answer with reason.
was 3.
B was worth 3, C was worth 3, and D was worth 2.
Okay.
Any other questions on the test? Okay, I want to revisit now problem set 1, because we had a couple questions the other day, and I thought about it, and I think I have some answers. So this is from the practice set. The first question related to number 5 on the free response. So remember, number 5 was that slope field differential equation problem. And I got stuck, somebody asked about number C, or part C, and I got a little bit confused about it. And we ended up with C was to find the particular solution of the differential equation, which we ended up getting y equals negative square root of x squared minus 8. And then it says state its domain, okay? State its domain. And I was a little bit confused because I was thinking, well, technically, x could be less than radical 8, or x could be greater than, or less than negative radical 8, or greater than positive radical 8. So I was thinking, why can't it be negative infinity to negative radical 8 union radical 8 to positive infinity? I was thinking, why can't it be this? Because the grading rubric said it's this, right? And so I got thinking about this. I think the reason why is the same reason why when you graph this solution, it just looks like this. It just goes like that. It doesn't include like the top part of it. And the way I explain that is there's this thing called a singularity along the x-axis, which means it's an undefined derivative point for some reason. Maybe that means that there's a hole in the graph or something. Maybe there's a hole in the graph. or some other discontinuity. Maybe there's a jump, maybe it jumped somewhere, maybe there's a vertical asymptote, or maybe just a vertical tangent. We don't really know what this looks like. So that's why you can't continue it past that point. Like maybe it jumps over to here and then does that, you know? Maybe the graph looks like that. We don't really know, right? And so that's kind of the idea here. When you have a particular solution of a differential equation, it has to be continuous for that reason, because if there's a discontinuity, then that means that there's a non-differentiability. So in the slope field, there's going to be that singularity thing happening. So just remember, like whenever you have a solution, a particular solution to a differential equation, whether you have to sketch it like you did in part A, or whether you have to actually figure out what that particular solution is like you did in part C, it has to be continuous. You can't have it in two pieces like this. And it kind of makes sense. We're having a solution to a differential equation. By definition, that has to be differentiable, which means it has to be continuous. Does that make sense? So just remember that. Like whenever you have particular solutions of differential equations, they have to be continuous functions. Okay? Continuous functions. All right. So that's what I came up with for question 5, part C. Then there was also a question on number 6, part C. So number 6, part C, we found the second derivative, and we ended up with g double prime of x equals x minus 2 plus b over e to the x. And the question says, find all values of b, if any, for which the graph of g has a point of inflection on the interval from 0 to infinity. So points of inflection occur when the second derivative changes sign, right? So you would set this equal to 0, and you get x equals, or x set the top equal to 0, x minus 2 plus b equals 0, which means x equals 2 minus b. Okay, so far? Now, if you think about this, there's a couple different situations that could occur. Think of this function right here. Like if I think of this function, y equals x minus 2 plus b, right? I could write this as x minus 2 minus b. If this is the same as that. The reason why I wanted to write it this way is because now it's just the equation of a line, right? It's a line of slope 1, and the y-intercept is negative 2 minus b, right? So there's a couple different cases. Case 1 is if 2 minus b is positive, right? If 2 minus b is positive, then this is x minus some positive number. It actually ends up looking like this, right? The graph would look like that. It has a slope of 1 and a y-intercept that's down here. But if 2 minus b is positive, that means this is the negative of that, or b minus 2. And this is 2 minus b. Does that make sense so far? Case 2 is if 2 minus b equals 0. In that case, it just goes right through the origin like that. So that's 0, right? And then case 3 is if 2 minus b is less than 0. In that case, you have x minus a negative number, which means that the y-intercept of this line is above the x-axis, like that, right? In that case, this is going to be, well, 2 minus b is negative, so that means this is the negative of that, b minus 2. And this is also, let's see, 2 minus b is negative, which means this is 2 minus b. Am I confusing anyone? I'm just taking an equation of a line, and I'm just looking at what if this is positive, what if this is negative, and what if it's 0. If it's positive, then it's x minus something, so it's this situation. If it's negative, then it's this situation, and if it's 0, then it's that situation. But we're trying to find points where, if you look at the question, it says it has a point of inflection on the interval where x is from 0 to infinity. So it rules out the other two situations. It has to be this situation, where that point right there, where it changes sign, is between 0 and infinity, right? It has to be that situation. Well, if you just solve this right here, this you get b is less than 2. Okay, so now we're at b is less than 2. So then the question is, why is it 0 less than b less than 2? Because that's what it says in the grading rubric is the answer. But why isn't it just this? Why is it this? That's my question. And the answer is, it says right in the problem. If you look at the very top of the question, it says b is a positive constant. It took me about a half hour of staring at this problem before I realized that they're actually just telling you it's positive. There's no other reason why it has to be positive. It's this. Okay? Does that make sense? That was a little bit confusing of a problem.
Are you collecting this at 11?
I'm not going to collect these packets. I'm just going to assume everybody did it. If you didn't did it, you're done. You should do it. Okay. I have another packet for you. This is problem set 2. It's due next Monday. It's due next Monday, and this Friday we're going to have another practice test.
The practice tests are just the questions that are not in the packet.
Yeah.
Also,
Right,
for
number
the most part,
one.
I won't be here next Monday. Do you want me to just like finish it by Friday? Because mine was going to next Friday too.
Yeah, that's fine. Yeah, that's fine.
Let's think here, Molly, don't be an idiot.
And I possibly won't be here Tuesday either. I'm going on a college visit in Vermont, so I just don't know how long I'm staying up there.
Okay. So I give you plenty of time to work on these in class, so there's really no reason not to do it. So I hope nobody takes advantage of my good nature, doesn't do it. That would be really foolish of you, don't you think?
Question, can I go to the squid ones right now to drop off?
Yes, yeah. So tomorrow, I actually did want to go over a little something. So you will have time to work on this Tuesday, Wednesday, Thursday, but tomorrow I just want to give time to talk about something first. So you can get started on these, and that's it.
What is that?
Thank you.
Thanks.